Welcome Karima Patel and Julieta. A few ladies here today. 151. Resume here. Yeah, that's actually perfect. I said we're going to start 8:05. This is 1:45 to go. So, okay. That one's there. Now it keeps freezing. It was running fine for a whole while. For whatever reason, I can't see my PowerPoint preview of the next slide. So I might have to like re-share the slideshow. Wait, we got even a few more. Welcome to somebody just left, but who's new? All right, I am going to disrespect the counter. I'm going to start this off by starting the presentation in a way that I could see the preview. Bing, bada boom, bada beam. Okay, we are underway. So hello everyone and welcome. My name is Sanyan. With me is Mohammed. He's going to be helping out with any questions that come up in the chat or anything else. This is going to be a webinar all about book analysis using Python and Jupyter Notebook. So this work is based on a unit of work I published on the Digital Technologies Hub, which is the main place. By the way, am I sharing this thing?
No.
Oh, that was it. So the webinar today is based on this unit of work I published on the Digital Technologies Hub. It's basically linked in that resource link, and I could drop it in the chat later. Mohammed, in fact, you could look it up. Yeah. Book analysis with AI techniques, and drop that in the chat. So this was actually done for high school students, and it's being used by hundreds of schools in Australia. So the webinar here is basically building on that and doing some more advanced analysis and some data visualization on top of the data analysis. So that's basically that unit. It's a collection of video tutorials with some resources and quizzes that come with. It's completely free because it's funded by our kind government down here. So yeah, check that out. Now, natural language processing, what is it? So that's the field of computer science that basically is designed to use language and try to make sense of it and try to get computers to both analyze language for meaning and then synthesize language themselves. This is the Oxford Dictionary definition, the application of computational techniques in the analysis and synthesis of natural language and speech. The domain of NLP includes both natural language understanding and natural language generation. Up until recently, the generation was the very hard part, and something changed in July. So we're going to get a bit of an insight into that. But yeah, if you want to know what natural language processing is, it's the intersection of computer science, artificial intelligence, and linguistics. So that's that in a graph. Okay, so components. So you could think of it as a linear process where you analyze text by doing these steps. So first you clean text, remove punctuation. Perhaps you remove like words that don't carry any meaning. Tokenization is you categorize text into, nouns, verbs, adverbs, adjectives. Or break it into, tokenization is more often you break it into either word sentences, paragraphs, or chapters. Stop words is, I guess, a further cleaning of the text by removing words that have no meaning. Frequency distribution is basically an analysis of how often certain words appear. Sentiment analysis is a study of basically positive versus negative emotion in text, as well as bias. And tagging is the official categorization into nouns, pronouns, verbs, adjectives, and different types of linguistic tools. So let's actually go into these step by step. First up, removing punctuation. So this is how we're going to do it. There's going to be, so this is like the presentation part. We're going to do this in code quite soon. So you can imagine having a variable that contains all of these punctuation symbols and just using a simple string.replace method to get rid of all of them and replace them with nothing. So you can basically remove punctuation from a book worth of text with about 4 to 5 lines of Python without even using, an external library. So next up, so this is, by the way, an example. If you were to do this process, you would go from something that has commas, exclamation marks, question marks to something that has no punctuation. Next up, tokenization. So you can have, your original text, and again, a couple of lines of Python. You could break it into words, sentences, paragraphs, or chapters. You'd use the split method. So you could split it on basically double spaces, which would be paragraphs, single spaces, which are words, full stops, which are sentences, and so on. So a couple of things in the chat. Okay, I will find that JSON. By the way, we generate that on the fly when you run the function. So maybe the words.json isn't actually missing. It's something that's going to get generated when we run it. So that's a good question, Paul. Okay. Stop words. What are stop words? So stop words are words that are either extremely common or have little meaning. So built into one of the libraries is a list of stop words, and it's like I, me, myself, we, our, ours, ourselves. So as you can see, like they don't have any connotation in terms of actions being done or identities. So basically, if you take these out, text is easier to analyze. Next up, frequency distribution. So I think this graph explains what frequency distribution is. Like if we have a book, for instance, Harry Potter, you can study how often certain words occur. Now, once you get, say, rid of all the stop words, and perhaps you categorize it so that you're only looking at either unique words or what do you call that? Like a name, proper nouns, you could get a ranking that is remarkably informative about what's going on in the book. So I've done that with Harry Potter after just getting rid of the stop words, and you've got Harry, Dudley, Dursley, Dumbledore, Professor, McGonagall. So these are some of the key characters in Harry Potter, which become evident just by essentially running a function that puts the whole list of words in a frequency dictionary and then prints it out like that. Sentiment analysis. So there's two aspects to it. Firstly, there's polarity. So polarity is how positive or negative emotionally a particular piece of text is. So it could be -1, very negative, and 1, very, very positive. You've also got subjectivity, which is biased and neutral. So for example, poetry would be, either very positive or negative, but it would definitely be very subjective. So the more descriptive adjectives and descriptive nouns you use, the more subjective your text is. So if you put in like a manual for, I don't know, a lawnmower, you would expect subjectivity to be close to 0. But if you put in an article about the US election, you'd probably get something closer to 1. So POS tagging, which is part of speech tagging, this is something that makes me feel like I actually don't speak English, because that categorizes every word in a text into a part of speech. So and is a coordinating conjunction. So now for something completely different. So like, yeah, and is coordinating conjunction. Now is an adverb, for is a preposition, something is a noun, and so on and so on. So in terms of libraries, this is the one we're going to use for sentiment analysis because it's pretty much the easiest out there. So it's a collection of tools. By the way, it works in REPL. So this is one of the few libraries that works in like web-based Python IDEs. And yeah, it contains functions sourced from NLTK and pattern for the most part. So anything else to say about it? Yeah, it also has the ability to do tokenization, POS tagging as well, but I only use it for sentiment analysis. Now, this library is going to be something that we use throughout. So if you're running Python on your own computer, you could just pip install Textblob, or you can just do that through your Jupyter notebook. So it does something very interesting. It basically tags every adjective and emotive noun in the English language. And the way that was achieved, you could have a look at that link because it actually lists like every word. The way that was achieved was through study of restaurant reviews from Yelp. So basically they correlated adjectives with star reviews, and then they removed words that have double and triple meanings, and they came up with something that is about 80% accurate. So I'll show you some examples from Textblob. So if you write the word happy, for example, it's going to have 0.8, but it also, if you write a much larger sentence, I am today have no polarity, so it's still going to be 0.8. But if you add prepositions like very, that's going to increase the amount of happy. You could write not happy, and that's going to turn it into negative, and so on. So it has some sort of grammatical intelligence, but essentially it functions around having individual words have emotion-based tags. Okay, so we're also going to use NLTK, which is the primary, basically it's like the leading platform for building Python programs to work with human language data. So NLTK is basically the leading natural language processing library in Python. We're going to use it for tokenizing and tagging our text. So it also can like give you visual outputs and display parse trees, which are quite complex. So beyond NLTK, we're also going to visualize our programs using something called pandas and matplotlib. So these libraries are pretty hot in data science and actually science in general. And all they do is pandas can do all sorts of mathematical calculations. I'm going to use it to create data frames, which can then be represented in graphs. So it's a high-level data manipulation tool developed by Wes McKinney, built on the NumPy package, and its key data structure is called the data frame. So matplotlib is basically a plotting library, and yeah, it creates pie charts, graphs, line charts, as well as different three-dimensional visual representations. So I've covered what natural language processing is. I've covered some tools that we're going to be using. So now I'm going to give you just a couple of really brief examples. I want to make sure I'm sharing my computer audio. Share computer sound of where this is used in modern technology. So this video is taken from a Google demonstration of Google Duplex. By the way, like if you have any of those smart assistants like Alexa, Siri, Google Assistant, they use natural language processing to analyze what you say. So everything you say is converted to text, and then that text is analyzed. And this is what it looks like when they work really well.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second.
Now, if I had made it clear, this is a chatbot voiced by a person. So I believe that it's basically mostly synthetic voice, and that's an actual human being. And Google Assistant here is making a reservation, and this person thinks they're talking to somebody's human assistant. And I say,
Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
by the way, yeah, if you have a Google Assistant on your phone, it can already do that. That's like the Duplex reservation section. I'm not sure if that's still on with COVID because of restrictions, but yeah, that's pretty cool. Something else to show you, and this is sort of thrown a wrench into the whole study of natural language processing, because currently the most advanced tool for natural language generation is not using many of these techniques at all. It's a neural network that has read basically unimaginable volumes of text, and it's a word predictor. So you give it some words and it starts predicting the next word, the next word, the next word, the next word. So this has gone through 2 iterations. GPT-2 was last year. So this is a short video about a paper from GPT-2, and GPT-3 came out this year. I might, before we actually start with the book analysis, show you the briefest of demos, because I know it's a tangent, but that's like the coolest thing I've seen in a while. But I'm going to show you GPT-2. So,
and now let's have a look at how it fares with the text completion part. This part was written by a human, quoting, "In a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English."
So here's the text completion part. You give it that, and then it starts predicting the next word. It goes like, the scientists named the population after their distinctive horn, Ovid's unicorn. These four-horned silver-white unicorns, previously known to science. Now, after almost 2 centuries, the mystery of what sparked this odd phenomenon is finally solved. Dr. Jose Perez, an evolutionary biologist from University of La Paz, and several companions were exploring the Andes Mountains. It basically reads like a story, completely computer generated, and somehow all it does is, based on all of the text it previously read, reads everything that came up until point this word, and then predicts the next, predicts the next, predicts the next, predicts the next word. GPT-3 is so promising that they're actually not releasing it. OpenAI is basically an institute that generally puts all of their stuff out for free, but they're saying that the potential for abuse of GPT-3 is far too big, so they are not releasing it. So let me just let me show you one application that you can play. This is called AI Dungeon. Mohammed, you could put that in the chat. So AI Dungeon uses GPT-3 to generate stories, and it'll be more fun if, Mohammed, why don't you choose stuff? I'll go new game, single player. You pick a setting: fantasy, mystery, apocalyptic, zombies, cyberpunk. Pick a number.
5, cyberpunk.
Cyberpunk. I never had cyberpunk before, so this should be interesting. Do you want to be a cyborg, a cop, or an android, or punk?
Cyborg.
Cyborg. All right. So this will be interesting. Enter your character's name. Don't think too hard.
Anything star. Okay, cyborg.
Let's call him Neo. I don't know, because Neo's a human, a very human, but okay.
Yeah.
A cyborg living in a futuristic city of Zali. You have a bionic arm and a hollow band. You're walking down the dark streets and neon lights flash brightly as you pass. You see a person sitting on the ground. He looks at you and nods. So you speak to him. Hey, hi, he responds. Can I have some money, please? So you can say, sure, here is $200. Don't spend it on drugs, please. And it will generate it. He thanks you and runs into the alley. A few minutes later, a loud explosion is heard. The man is gone. What happened to him? So basically, this thing read thousands of cyberpunk novels and then is predicting the next thing. You walk from the alley, get to your car, you're driving down the streets, you know there's a small explosion before another explosion is heard. Oh. Go to the explosion. You drive into a large entrance in the park and park your car. Go to the top of the building. And it generates the story. You walk into the building and head up to the roof. Like, how does it, it associates top of the building and the roof. When you arrive, you find a man sitting in a lawn chair. Hello, you say. Hey, he responds. Did you hear those explosions? You didn't. He doesn't seem to be in a rush to do anything. You sit there and relax while you wait for something to happen. Okay, so by the way, this is actually one of the less impressive examples of AI Dungeon, but you should know that the most impressive language generation tool has absolutely no rules. As I said, it is a neural network that has millions of parameters and just predicts word by word the next word. So back to our topic. This is the collection of programs. This was on GitHub. Now I'm going to talk about tokenizing the text. And I think there was a question from the audience about the source of the JSON files. So I'm going to explain that in a second. So let's, in this case, our book is Harry Potter. And we can, in here, just open up the book and print it. So I'm going to run the cell. And yeah, that is the entire Harry Potter book in there, right? And I've saved that as a variable text. Cool, I've got the chat. Can we access all these? Yes, there's a GitHub with all of these programs. I can send you the repo. It was linked at the start of the presentation. Mohammed, in fact, can you go to that? I'll give you the resource link right now, Head Start Academy. And in here, free resources, book analysis. All right. So all panelists and attendees. Okay, so in there is a link to the GitHub repo with all of these. Okay, so here are some functions that are going to tokenize this text. So this function, like I said in that presentation, you have a string here that contains all of these characters, and you can replace each of these weird characters with nothing, and that removes all the punctuation, right? The string then returns the new text, which has all of the punctuation removed. The word list, I've actually used the word tokenize from the NLTK library. To be honest, I've done this about 3 months ago, and I forgot why I used word.tokenize. But you could basically use text.split, and that's going to create a word list. The only reason why you would use this is that sometimes, like Mr. Dursley, the tokenizer from NLTK might actually take separated text to be a single word. So, but yeah, there was a good reason why I chose the tokenizer from the NLTK. but for the life of me, I can't actually remember it. So sentence lists, that you basically do the same thing. And there's a very good reason for this particular tokenizer, because if you split the text on full stops, then a word like Mr. is going to be a sentence, right? So if you split the text on full stops, you're going to have sentences made up out of things like doctor or Mr. because there's a full stop there, and it's so that the full stop isn't splitting on a full stop is not going to make good sentences. So whereas a paragraph list, I mean, this does the job. You split the text on 2 spaces, then that makes you a list of paragraphs. So if there is no word chapter, by the way, you can physically add the word chapter at the start of each chapter. So generally speaking, when you're going to analyze a book, you're going to need to double check if there are any punctuation symbols outside of here. And if you want to separate out chapters, you got to think about how you cut that text, and splitting it on the word chapter is probably the best way. And if that word is capitalized, then that's pretty much foolproof. So here are 4 variables: words, sentences, paragraphs, and chapters. So now, like that, we're going to go embark on messing around and trying to find out, who the heroes, villains are, and then how the emotions flow through the text. We can use these 4 variables, but in order to be able to use them in future programs, I've basically permanently stored them in these JSON files. And these JSON files are going to get generated when I run this cell. So I should be able to, So last time I ran it was when I did this webinar 2 months ago. So I apologize if I'm a little rusty on some of this stuff, because that's the last time I've actually done this. So the reason why I store them is because you're going to use words, sentences, paragraphs, and chapters, and basically permanently saving them on the server or hard disk or some local file is going to make our analysis faster rather than having to run these functions. I mean, they take 20, 30 seconds each. And here are some just test codes. Oops. This is some test code, for example. First 20 sentences in the sentence list. So, I mean, that's categorized as a sentence. That's categorized as a sentence. But so these are sentences. You will notice that sentence tokenizer left these full stops in, and that's why I use the sentence tokenizer from NLTK. So first 20 words in the word list, that works, self-explanatory. The first 20 paragraphs, I've created these sort of lines in between. So a paragraph is anything that has basically got 2 spaces between it. Now, some of this is, I'm not sure if that is exactly a paragraph, but this is not super accurate. Paul, I don't know if you can just let us know in the chat if you're running this through Jupyter Notebook. The actual open is what generates the lists. Depending on what IDE you're using, you can just create a blank words.json, and then maybe that's how it's going to work for you. All right. So that, last but not least, chapters, and they're quite easy to tokenize. So that was chapter 1, and I think there was a chapter 2. Okay, so now into the first interesting thing. So we are importing the following packages. So we got the word tokenizer, sentence tokenizer. So we're using this frequency distribution from NLTK. We're using stop words, and we are using the POS tagger, part of speech tagger. So all of these are NLTK tools. By the way, I'm pretty sure we're not using these. These are just sort of left over from the previous one. So let's, as you can see, I'm just loading that JSON from that previous file instead of using that, using the function in the first place. So the first thing that I'm going to do is create a frequency distribution. So that has every word in the book and how many times it repeats, right? So you use this frecdist function right here. So that's going to have Harry. That's how many times Harry repeats. Potter repeats that many times. Toot repeats that many times. Say repeats 72 times, and so on and so on. So now my goal is going to be to basically rank this. So if I have all of the words in the text ranked, this should give me something interesting, right? So you can use the sorted function in Python. So the sorted function is going to take the parameter of the dictionary. It's and going to give you a ranked list in order of the most repeated at the top. The default, if I didn't say reverse equals true, would be the least repeated. So now you can go cycling through that list and just print out basically the key and the value. So the, to, and, a, of, right? I mean, these words are the most common, and then Harry, and then wasn't it this, he said, etc. This is not that interesting. So we got to start filtering out some words. So what are we going to do here? Okay. So in this next cell, we are going to eliminate stop words. So we're going to, if you can get them from NLTK, and I'm pretty sure that like this was code that I was testing that you can actually, if you use the download, you can get particular, I don't know, parts of packages or sort of, what's the best term, files within packages with this download function. I don't remember exactly how it works, but nonetheless, stop words are those common English words that carry very little meaning. And this is where we define that variable. So this is going to be a list of those words. And right here, we are going to go through all the words in our ranked list and remove everything that is in stop words. You can actually also remove manually words that like didn't make that much sense. So all of a sudden, Harry said, so sorry, didn't receive the link till quite late. Any links or info? Yep. There is this one. So as you can see, this is a lot better. I mean, we got rid of the stop words, but it's still like said, won, got, didn't, like, could, no, get. So this isn't exactly super useful, but it's already a lot better than it was without the stop words. So what's next? So next we're going to tag the words. So that means that every word in that in the word list is now going to be tagged as noun, pronoun, verb, adjective, etc., etc., etc. And what we're going for, and this is a Python list comprehensions, basically going through that tagged list. So that each word will become a tuple with the word and the tag. And now we are isolating proper nouns, basically words with this N and P tag. So now, if the word in the ranked list is a proper noun, and it's not in the stop words. So now we're filtering out the stop words and basically only taking proper nouns. Now we're going to print that ranking. And now we got Harry, Ron, Hagrid, Hermione, Professor, Snape, Dumbledore, Dudley, and so on. So all of a sudden, what you really have is the characters within the book. I mean, you might have like Gryffindor or Hogwarts, so names of places, but proper nouns are basically names of people and names of places. And all of a sudden, you're sort of at least finding out who is in this book and where it takes place and so on. You can also, just like we ranked all the proper nouns, you can rank all the verbs. And, I mean, to be, to have, to back, to like. Backing is like a common verb in Harry Potter. Like, know, do, think. You would think that like there'd be magical stuff, like casting a spell or something being the most common. But No, it's really like common English verbs. Weirdly, Dragon made it there, so that's the only like odd one. Again, what I guess one of the common themes is, no matter what whether you are tokenizing or categorizing text, it never approaches like 99% accuracy. Like the best you're looking for in terms of how clean your data is, that's a technical term, is about 90th percentile. So what was this last thing I did? Oh, yes. So the dictionary of all of these common proper nouns, we can now use pandas and matplotlib. So once you import these two libraries like that, it is a matter of these two lines right here. So this creates the data frame. So the data frame takes in this filtered dictionary, which is essentially what you're looking for. What you're looking at, I believe, where did I create the filtered dictionary? Right here. So that is the list of proper nouns and non-stop words. So in this cell, you're going to print that data frame. So you're going to see what the data frame looks like. That's it. And then you are going to use the plot in terms of bar. We're going to give it a title, Harry Potter protagonist. So there you go, Harry, Ron, Hagrid, Hermione, professor. So there was a problem here that I ran into, and I did a bit of research, and because, you know, if you have professor, that could be this Professor Snape, but there's also Professor Dumbledore. One's the good guy, one's the bad guy, or the quasi-bad guy. So can you use these tools to figure out multi-word names? So this is again a part of the repo. So it's going to be in the resources. It's a function that I'm not going to go through in detail, most likely because I don't exactly remember how it works. I basically got it off of this thread on Stack Overflow, but it just demonstrates how you can get multi-word human names. So have a look. It's currently crunching all the text and printing them out. That star means that the cell is still processing. So it's using, there is like a built-in parser that actually has human names. So this is not doing anything from first principles, but there you go. Madamalkin, Harry Potter, Fantastic Beast, Albus Dumbledore, First Class, Grand Sorcerer. But there's some wrong ones, like make Harry, make Dudley, like make is not. Bonfire Knight, Albus Dumbledore. So again, you're sort of seeing that pattern about 90% accurate. So we could have used these multi things for human names and ranked those and then compare that data. In fact, we did. I believe I have ranked them here. So as you can see, Uncle Vernon is the Professor McGonagall, Aunt Petunia, Mr. Dursley. So these are some common names. And so all of a sudden, when you start ranking it, all of that like goofy stuff, like make Harry and make Dudley goes away. So now going back to the sort of tokenization, we had chapters. Now I'm going to try to look at sentiment analysis. Now, sentiment analysis is remarkably simple in terms of the amount of code. So this is the import from Textblob, import Textblob. And now I've got this chapters file, again, which was saved in that JSON. I could have just, if you remember, generated the chapters with this function. And I'm now going to create a dictionary where basically the chapter number is the key and the chapter is the value. So and then I'm going to print out the polarity, meaning the emotion. I'm surprised I didn't print it out. I must print it out in the next cell. So yeah, chapter 0, Yep. Because when it slices off anything above the word chapter is going to be chapter 0. So that's fine. So chapter 1 is slightly positive. Chapter 2 is slightly positive. So chapter 3 is slightly negative, and so on. So this is it. The number of the chapter and the sentiment, the value between -1 and 1 of how emotionally positive and how emotionally negative the chapter is. And now I'm going to put that in a bar graph. And there you go. That's like the emotional arc of Harry Potter. Happy, though, crisis, happy, some crisis right before the end, and finishes happy. So they like, you can like see the emotional flow of the book just by sort of taking the sentiment analysis of each chapter. And just for the fun, you can like print out the line graph. Again, these are remarkably easy. Like so you create the pandas data frame from here. So the parameters are, the dictionary that goes there, the orientation, and this iloc basically just says, go from 1 to 18. I wanted to remove chapter 0 because there's nothing in chapter 0. So yeah, that's how that stuff works. So now heroes and villains. So let's go through this. So we're going to use paragraphs, words, and sentences. And now we're going to create this fun function called protagonist score. So the way it's going to work is you're going to go put in a candidate, which is a word, a bit of text, like a name. And you're also going to give the book in tokenized form, for example, a list of all paragraphs. And then it's going to see the emotion associated with that character, paragraph by paragraph, and give it a higher score when the emotion is extreme and a lower sort of positive or negative score when the emotion isn't extreme. And then it's going to return the score. So now these are like the 4 houses of Harry Potter. And you're going to see how this protagonist score works. So like Gryffindor is the Harry Potter's house and he's the hero. And like, that's the most positive. Slytherin are the evil guys. But funnily enough, all of the other 2 houses are also even. And the Ravenclaw, I think these are the sort of cold-hearted intellectuals. Hufflepuffs are really nice. So the Ravenclaws, these cold-hearted intellectuals seem even worse than the Slytherin, who are, the sort of selfish, career-oriented people in Harry Potter, or I guess they're the servants of the Dark Lord Voldemort as well. So you could basically put anything as a parameter here, just for the fun of it. You can check out right here, like Hagrid, who was a helper of Harry Potter, who's a good guy. You can check Ron, who's Harry's friend. And you're going to find out if they are heroes or villains. So let me run this whole thing again. And yeah, they got very high scores, both of them, much higher than much higher than most houses. So both Hagrid and Ron are correctly assessed to be, positive characters on this protagonist, like hero villain score, protagonist score. So what do we do in the next cell? Right here we got a dictionary that I'm forming called protagonist index. And right here for candidate in ranked list, so that was the ranked list of all the characters. If it's proper noun and everything, I am going to print out the protagonist index of that character. So how positive or negative each one of these people is. So where are we? Let's print that out as a dictionary, so that should be the name and then their protagonist score in order at which they're ranked in terms of popularity. So when we print this out, Harry should be on the top, and then Professor, and so on and so on and so on. So let's Yeah. So yeah, Harry, Ron, Hagrid, Hermione, and so on. And I'm sure that in the next cell, I print that thing out as a bar graph. So the most positive person is actually Dumbledore, which is the kind-hearted, good professor that takes care of Harry throughout the book. No surprise, Snape being the villain is correctly assessed. So, I mean, like Neville Longbottom is a good kid that bad things happen to. So basically the only sort of flaw of this, the only character here that's gotten completely wrong is Neville Longbottom, but it's not really completely wrong. It's just that the, if bad things happen, it could be that the chapters or the character covered is a villain, but it can also be that bad things happen to a good person. But yeah, you know, that's still that is still about 90% accurate in identifying heroes and villains in Harry Potter. And maybe even if you hadn't read the book, you would be able to talk to someone who did and make some, you know, sound predictions about it. Finally, character journey. So this is, you can think of this like any character in the book and their emotional arc. So like what happens to Harry as the book goes on. So I recall when I built this, I had a problem because a lot of characters, like you don't hear from them in like 2 chapters. So they appear in chapter 1 and then 5 and then 8 and 9. So what I did here is I've created a list of sentences. So this is like, as long as it needs to be, a list of sentences that mention the character. So instead of running through it by chapter, it's basically you create a new giant list of each sentence the character is in the sequence of the book. And then, that so far is just that list of sentences that the character is in. So after that, I have this function called a character journey, and then character journey cumulative. So this is basically character journey where the sentiment is just a value for this sentence or this set of sentences, using the sample size here. So sample size will choose how many sentences. And here it basically, character journey cumulative is exactly the same function where it just adds up all of the emotion. And let me run that. These are just functions. Nothing's going to happen. So now I'm going to pick Hermione. And this is like a section of this is basically printing samples from the sentences that are about Hermione. I just wanted to read them. Now here though is the actual character journey. So I don't know who the character is, journey of Hermione. So you could put any character in the book. Right here, we have identified the protagonist to be Hermione. We can rerun this with a different character. But yeah, the Hermione starts off neutral and then becomes negative, then positive, and she comes really good at the end of the book. She keeps annoying Harry. I do remember, like, this has been so long since I read it. Mohammed, have you read Harry Potter?
No, I've seen Harry Potter, but
you've seen the movies.
Yeah.
Right. But yeah, like that's basically like if you've grown up in Australia or the States or England, unless like you're, I don't know, in the States, like the fundamentalist Christians are up against, they hate Harry Potter. Yeah. So you could basically, I hope I've explained this sufficiently well, but going through that, instead of going through chapters, you just go through all the sentences that the particular character is in, and you see their arc. So if we say Harry, and then run this and that, whoa. So for Harry, I mean, this will be interesting. Maybe we can change the sample size. Instead of 10 sentences to make it 50. And that's going to be the cumulative. And I wonder, so I can change that to JC and have a look at what the cumulative one is like. Is that printing or not? So yeah, that's Harry's journey. So he's kind of sad at the end, I think. I don't remember why, to be honest. But let's actually change the journey to the cumulative one and just see how the graph is different. So yeah, overall, Harry's experiencing good things throughout more than bad things. So when things go down, he's experienced something good. But there are Harry is consistently associated with positive emotions. So if we were to put in Snape here, I'm sure it's going to be, the graph is going to be going in the opposite direction. Yeah, it actually goes up, but it stays negative. Cumulatively, Snape is still negative. And again, Snape doesn't appear all that much. So I've probably gotten the sample size way too big. So why don't I make this 10 and then maybe Snape is going to get a more meaningful. Yeah, that's Snape's graph. So he starts off being super bad and then he kind of gets, I guess, plateaus in his badness and becomes less bad. But generally speaking, like this is sort of a way to data science your way around the hero's journey. And the way that hero's journeys typically work in books is things are good and then something bad happens and then they go down and wrap up back in sort of the positive domain. So I don't remember what that last data frame was. Because that was both the graphs. I believe that was the JC. That was the cumulative one. Yeah, I don't know why I was changing this when I had them both. But there you have it. This is a good set of tools to play with. By the way, let me show you one more thing. Project Gutenberg. Here's a place where you can get all the books you want in terms of getting text files for them. The homepage has changed a bit, but yeah, like these are some books I've gotten here. So if you type in Alice in Wonderland, there'll probably be five published editions that you can get, and then you can get a text file of that. Just pick one that has a lot of downloads and see you can get a plain text version. Oh. Alice's, what about this one? EPUB. French. Plain text. Yay. So this is where you can get the text files. You can download them, and then you could basically plug different ones into the algorithm and then analyze a different book. And as you can see, like most of these text files tend to have chapter written in all caps, and then you can split chapters like that. So that's quite convenient. So the link for Project Gutenberg is gutenberg.org. That's where I got the Harry Potter books from. Weirdly, Project Gutenberg, last time I looked, didn't have the Harry Potter books. I don't know if status of Harry Potter books changed, but you know, there you have it. So yeah, that's where we're gonna wrap up. I wonder if you guys have. Do you have to clean Gutenberg book files before loading them? Usually there's 3-4 versions of everything, Paul, and then you just find the best looking one. One thing that I've had to do is when I run this function, I will find that there's some other weird symbol. But then whatever weird symbol I have that hasn't been cleaned, I paste it into here. So there is a remove punctuation function built into NLTK, but I prefer to do it manually because books tend to have just an odd weird symbol that just lingers in there, and then you do clean it. But yeah, also, Paul, you've sorted yourself out with the JSON files, right? That's all good? Got it. Sweet. Yeah. Paul looks like he's on top of his Python and data analysis stuff. Cool. Let me just, yeah, we had download some NLTK stuff. Cool. I would also try, like, Google Colab is becoming probably even more popular than Jupyter Notebook. So you could check that out as well. It has a few more automatic imports than Jupyter. So yeah, guys, that's going to be everything. I will hang around for another couple of minutes if more questions come in. I'm of course happy to answer them. And yeah, by the way, one question to everybody there. If there are any teachers, let me know in the chat, because what I do for a business is I do ICT extension, basically coding extension. Teachers select small groups of students, and I mentor and teach them Python throughout the year. I also teach myself part-time, and that's my part-time occupation. And yeah, I've been doing that a lot since COVID hit. So if there are no questions, we're going to wrap up in a minute. I'm just curious, Mohammed, do you have any questions?
No.
I'm putting you on the spot like that to fill in, but
yes, well thought.
Cool. Yeah. Again, this is the only thing that I would tell people out here that I regret not finessing a little bit. I've pretty much copied and pasted these from all the commonly used ones. So the ones at the top are not necessarily all used in the actual notebook. So be aware of that. In case I don't get to say later, thanks for sharing the materials, organizing the session. Yeah, you're welcome. You guys take care. I'm just going to stop that YouTube broadcast. I don't know where that is. And we are going to wrap up now. Thanks, everybody. Bye.
Bye.